T2 demos. T2 demos. T2 demos. This is the first test to try to do time-lapse with the X-T4. There's the parameters. We're going 300 times. Speed up, these are JPEG frames. There's lots of problems with this, but it's fairly encouraging. I'm worried, since this is just one power zone, I'm worried about when we get to like 9 power zones, whether there's going to be enough res. But we'll see in the second demo where I do some camera projector automation, I'm calling it, that it looks pretty good. We can push from here, we can push all the way into a single tile after the fact and still like read the text, for example, which was not really true with the previous solutions. I don't know if that will still be true with 9 power zones, but we'll see. So this was a big update of almost everything, because I hadn't had this grid fired up for quite some time. I've been working on the single ring, and then obviously just doing a Hugene run, which I wanted to run until it settled one way or the other all by itself, but I didn't really understand how the Fuji X-T4 works, and its battery died. So that's where this simulation ends. All right, so here we are pushed into a single video, also with a little bit of color grading, since the background of the CDM menus really should be brown. And the LCDs we're using are really so low quality. So I've just tried to get this to approximate, to sort of emphasize rendering what passes for true colors on the LCDs, and let the the T2 tile cases and the surrounding environment and stuff go hang. But I'm also, and this is using the Kdenlive transform effect with keyframes that are set to smooth, which is cubic splines, I think, and I'm starting to get them working. You can see that this is actually fairly smooth, and it doesn't have a lot of changing in directions that don't make a certain amount of sense given the action on the screen. So this is it. This is the first test. I've now got an order for one of these dummy battery things that connects to a charger so that it's not relying on USB power. So hopefully we'll be able to do much longer. Lots more stuff to do. Just figured I'd put the first test up. That's it. It's been a very long road from this spike, huh? No membrane. Just a random chain. A random open-ended chain. Not a loop flopping around. Happy New Year, Ben. Let's do this. To build new life in 180 days. Alrighty, that's the transfer tile. Alright, we'll let this propagate and then we'll start it up. Okay, folks, we did it. T-0. Grandchildren for the ancestor. That was the goal since June, July. Lots to talk about. Let's just get going. Where are we? Okay. Yeah. Okay. So first off, grandchildren for the ancestor. Here was the overall timeline. We actually stuck through it pretty well, assuming that we can ditch the simulated evolution stretch goal. Had a typo in there the whole time, but now we're one day later. And a lot of this stuff doesn't work as well as calling it all green really might imply, but we'll talk about it. So the goal for today, grandchildren for the ancestors on the T2 tiles. That's exactly what we just saw. Even though the very first reproduction by the ancestor had one failure and one live birth, that right daughter went on to produce two more copies of the ancestor code. And there's a bunch of wild stuff that we'll take a look at a little bit in a minute. And so, yeah, had some pretty good fun. But I said all along that I felt a little confidence about being able to do this because I was willing to cheat as necessary. So what I mainly want to talk about here is the kind of cheats I did have to make and the kind of cheats I didn't have to make in order to get it to work. So that's the cheat report. So first I want to have a bunch of disclaimers. So Ancestor 1312, that's version 3, subversion 2 in, Lex Limited. So is Ancestor 1312, is it a von Neumann universal constructor? I mean, that's sort of the holy grail. I mean, it's been achieved in the land of synchronous, deterministic, ka-chunk kind of stuff. But I want to say what we have here, what we just saw, is absolutely not a universal constructor because it's not clear what universal really means. You're supposed to be able to make anything, but how big is anything? The way 1312 is designed, it does all of its building during its reproductive cycle inside the diamond grid, and that is very finite. So you can only build things like that. So I don't even want to play in the universal constructor game, and I want to say what exactly universal machine is a little bit unclear. Is it a von Neumann style self-replicator? Yeah, it absolutely is. It's legit. So how do we evaluate it if we can't evaluate it on universality? I want to apply the strict Lego quality theory. This is a theory I made up. And the key question for strict Lego quality theory is how many different kinds of parts does it use? And so if you could build something out of just one kind of part, the 4x2 white Lego brick, and you could just have zillions of those, then your cheat level would be extremely low. One piece. On the other hand, the notorious Millennium Falcon kit that has, I looked at the webpage this morning, it has, as far as I can tell, over 650 different kinds of parts, including all kinds of little nubbles and knobbles, and it has a sheet of stickers that counts as one part. This is like total cheating. So where does Ancestor 1312 fall on the strict Lego quality cheat spectrum? Well, it doesn't do very well. For one thing, we've got 208 classes. So, Ulam, the language it's written in, is an object-oriented language. You define classes to do stuff. We've got over 200 classes. And by contrast, in the synchronous deterministic universe of traditional cellular automata, the von Neumann universal constructor that's out there is at 29 states. And a Ulam class is considerably more powerful than a state in a state table. And so, they're not really comparable because I wasn't trying to minimize the number of Ulam classes. I was trying to make the code understandable so that I could get the engineering done and actually get this stuff to work. I have a whole bunch of complaints, other things that so the zombies, if the reproduction fails, if we don't manage to get code inside it, don't you think it would be nice if the grid would just pop? Well, but it didn't, because it came from before, when it used to be the case that there was no code, so they were floating around. So we need to redefine some of the underlying physics to do better. And my biggest sin was the cell division process, which worked sometimes and not sometimes, uses timers to decide how far to go. And one of the things I learned is you should never use timers. You're in a state of sin if you use timers in a deterministic system. In a distributed system. In a deterministic system, who cares? In a distributed system, what you want to do is have some signal set out in the world that becomes visible to you when you can go on to your next step, and you make signals that are visible to others so that they can tell when they can go on to the next step. And so nobody has to just sit there and go 1002, 1003 and then go. But cell division uses timers. Complex instruction set, so blah, 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 bunch of stuff. But again, the fundamental aspect of it is right. Okay, open-endedness and robustness. So we got grandchildren for the ancestors. So officially speaking, I am not ashamed we adopted this 6-month target, and we made it. Well, what happens next? So part two, we'll take a look at it, is as of up to this past midnight, just what's happening on the grid. It's still going, so let's take a look. There's some wild shit in here. Successes. Side-by-side births, adjacent hospital beds, one zombie though. It's always the left daughter, because that's just the way the geometry works, or at least under normal circumstances. Let's see what's coming up here though. Yeah, look at that. That diamond got a whole chunk of it chopped off, and then it healed itself. Same thing happened down here. It healed itself, and then it went on to reproduce. Can you believe that? So this guy down here, he was half sliced off, and there's another half sliced off bit. He healed up, he reproduced, and now he's having kids. She's having kids. They're having kids. Mostly now, they've grown until they're locked up against the edge of the universe. The same sort of thing we saw with the zombies, except now, when somebody pops, the space gets available. The space gets taken. So, this is... I never saw any of this in the simulator because I never let it run long enough. I never had things reproducing as close to each other as they could possibly, and so forth. The cell division mechanism is quite strong. It's quite powerful. If it sees hard cell 3, it's going to go and cut through it until it doesn't see it anymore, and then it evaporates. So if it gets close enough to a neighboring grid, a neighboring diamond, it can just do what we saw. So all of that was, in a sense, free robustness. Okay, Living Computation Foundation. First off, welcome to our newest Living Computation Foundation nerd, Francisco, LCFN 250. Thank you so much for joining us. In the publication divisions, I'm bringing this up because I am really itching to write more English, and that potentially competes with writing Ulam or Splat or code in general. There's just only so many hours in the day. So I don't know exactly how that comes out, but it's going to be an issue going forward in 2023. Hoping to publish Companion at Caring, my dad's manuscript, in February. We'll see if that happens. Okay, and next steps for the T2 tile project, finally. First off, gotta write up Ancestor 1312. It won't be Ancestor 1312. I'm currently on 1315, and we'll be down the road from there by the time we lock it down to do experiments for publication. But write this up somewhere. The inside track would be the Artificial Life Conference, A-Life 23, which is going to be in Hokkaido this year. I would not be able to be going in person, but it's a hybrid conference. Or perhaps submit papers somewhere else. I am pushing the cadence for T2sday updates back to the first T2sday of every month. It's sort of hard for me to believe that I did weekly for as long as I did, and even bi-weekly is feeling, on the one hand, I feel like I'm kind of trained at this point. I do want to get the work done. I'm feeling that, there's not a lot of time and a lot of stuff I want to do. So we'll see. We'll see. I think a monthly cadence hopefully will be a little bit more easy to manage and have a slightly higher quality stuff. Can go a little deeper and a little less of the, midnight before the assignment is due. We'll see. And then there is this question. So we're done with Grandchildren for the Ancestor. Check. Mission accomplished. Uh, do we want to adopt a major development challenge for 2023? If so, what would it be? I know what it would be. It would be building on what we've got here, these individual little cells that are capable of reproduction and motion and all of this stuff, and figure out ways to let them communicate with each other, signal between them, and do multicellular system control of some sort. And it would be even unbelievably much more slow and taking unbelievably much more hardware to do the simplest task. But again, that's the point of the demo. Write more English and write more Dave Ackley channel videos. People have been asking for it over there, and I feel like that would be a good thing to do. In addition, or instead of, that's the thing. So I'm not sure how much to be the main focus to keep pushing on the T2 tile code base for now. Hesitate to say for now there. That feels like a rationalization. I don't know. Well, so we'll see. So that's it. The next T2sday update will be on February 7th, the first Tuesday in February. My goals are to kill zombies. I've gotten that somewhat better, but also structurally change the physics and get the ancestor to do more cool stuff. Think about R&D, whether to do it, and have a little bit of fun every day. Folks, thank you so much for dropping in to check it out. Happy New Year, and hope you have a good year. I hope to see you next time. Alrighty. Well, that's that. And I guess, hopefully, I'm still at... Yeah, Ben, I hear you. It's funny that the zombies keep growing. It's embarrassing that the zombies keep growing. But, alright, I'm going to stop recording. But that was a side effect of bottom-up engineering. The zombies were out there bopping around long before there was any ancestor code that could possibly make them be under some kind of control. So I got to retroactively go back and provide a mechanism for an exterior control to come in and take over, essentially be a parasite on top of the root code that's in there, and then change the root code so that it depends on the parasite, so they become mutualists at some level. And if the control code isn't there, the thing will pop. The thing will pop more quickly. Okay, let me get this rendering, and then we can chit chat if there's anything more going on. I have no idea what the. I mean, one of the things that's weird is the all the code motion, the copying from the middle to the left, and then the level over the right. That's all counted out, pocket by pocket. Go 9 pockets to the left, plant the diamond sequence to there. Go 18 pockets to the right, plant a diamond sequence to there. It's actually 17, and so on. That are all based on the idea that a fully grown cell is going to be radius 18, which means it's 0 and then out to 17 in every direction. Uh, um, and all of the tests that I was doing in the simulator, that was always the case. But the ancestor code doesn't actually check that the that the diamond has reached size 18 before going on with any of its steps. A lot of the times, like if the diamond is very small, when it tries to put out the construction arm, it'll run into the edge of the thing, and the construction arm just won't continue because there's no pockets there. So it'll automatically block until there's enough room to put down the diamond sequencer. And similarly, when we're copying the code in, unless there's enough room to make spots, everything will just block and push back. But then later on, once it gets to the point where we're trying to decide about the cut, it's all about the cell division. It was always, it had reached its maximum size by then because everything was so slow. But uh, with the stuff going on in the grid now, where it's just absolutely packed solid with big zombies, little zombies, people at all stages of reproduction and growth, I think in some of that part 2 stuff, there were some replications, some of which succeeded, that were not at the full size, even though they had been put, 18 sites apart because they were expecting to have 9 on one side, 9 on the other when it was all done. But they managed to get away with it. So that's just, another example of, what's going to happen? I don't know. Is it going to actually reproduce successfully? I doubt it, but I don't know. And so we'll see. So, and again, I'm going to leave 1312, even though, like I said, I've got improvements already on MFMS. I'm going to let 1312 go for at least a week or so on the tiles if all goes well and don't have any power glitches or whatever, and see what develops. Just in honor of it being the first one that actually got to exponential growth. It had enough births that I don't know. We'll see. The big zombies need to check out. They need to. We need to lock them up so they can't move, and their watchdog timer will start to grow, and then they will pop, and that space will become available. And we just have to hope there's enough, because the same thing's happening to the fertile grids. If they can't move either, the watchdog timer in their grid route is also counting up, and they're going to pop if just depending on the breaks. So we'll see. But it seems to me there's a lot of copies, a lot of apparently functional copies of the ancestor code now on the grid, on the 3 lotuses. So we'll see. Like that. That's what I think. And all right, and the rendering is still got a little while, and so I guess that's it. So we're at 12:30. Maybe should we call it? Since everybody's got their New Year's resolutions to. Did I make any New Year's resolutions? No, not really. I mean, I make bi-weekly resolutions. Now I make monthly resolutions. We shall see. Yeah, can you make the cut line only go through so many parts? It's all about how much smarts, you want to build into the cutting line. Uh, um, at the moment, it just looks for identity. If I see an HG, an HC3, the growing kind, then I don't like it, and I tell all I flood the direction I'm heading in with more of me, and as long as anybody in the neighborhood sees one of these things, they continue to flood outwards, and that's why they actually will flood over a hop to another one, and you can try to figure out if this HG is part of the same cell as the other one by analyzing the gradients on it, but it's not easy. It takes a chunk of little code, and there are corner cases that you're still going to get wrong. Uh, um, so I'm not sure. I mean, it could be. I mean, I designed the splitting stuff to be very aggressive. So when it sees one of these things, it fills a 3 wide diagonal, its entire event window. It fills it up so that it will outrun any mere pokey HC3 grid stuff like that. Because that's its goal, is to separate the two sides before they change have their new roots and their new sizes and all that stuff that can mess each other up. But now I've made some improvements in the grid, and it may be the case that we don't need to have the split atom be that aggressive. And so instead of filling out its entire thing, it could maybe just fill out a local neighborhood, distance 1, distance 2, something like that, in which case it wouldn't stick out so far beyond the edge of a given diamond that's undergoing cell division, diamond cutting. And so this would presumably be less of a problem. The chance of it jumping would be less. So that might be a simple thing that could be tried like that. Yeah, some kind of vault to repopulate. I mean, I really love the idea that the original ancestor code is only used once. And what I really wanted to do for a demo is like have a USB key or something like that. That you'd put a start symbol on the grid, and it would just poop out. It would say can't do anything. But then you stick the ancestor code into one tile, and you hit the start symbol there, and it says, "Oh, I see code for an ancestor," so it sucks in one copy of it and puts it into the ancestor. And then you pull out the USB stick, and now the ancestor code is nowhere in persistent storage on the grid. It's only in the cell bodies like that. And then you see how long it can preserve that thing entirely by life replenishing copies of it, by life making copies of it, and when it goes, it's gone. Jeff Hinton, one of the gods of machine learning, who was also my PhD advisor, is now talking about mortal machines, and it's a similar idea. It's machines that do machine learning, but they don't. You never dump the weights. These things are so complicated, and they're all unique, and they compensate for their own flaws by learning around them and so on, so that each learning, it has some kind of core that it's probably delivered from the outside, the evolutionary heritage, but then it tailors it to itself, and when that particular piece of hardware goes, that machine is gone too, and it's inherently not back upable, because it was all self-tuned for the specifics of the data, the input, and the kind of hardware with all the little whatevers it has like that. So Mortal Machines is very much in the spirit of what I would love to do here, where the ancestor is now, there is no copy of it. It could have come from on high and then left, and now it's up to the living systems to see how long can you improve it. And eventually, yes, it will be time for the living systems to evolve it. What I would love to see is evolution just happening, just accidental evolution on the T2 tile grid as all of this stuff is happening and the split atoms is coming through, and sometime eventually it'll take some little bit of the chain and connect it to some other little bit of the chain, and the local chain won't notice a problem. It'll be clean enough that the chain won't suicide. The chain won't disassemble itself, and then it's a new thing. Yeah. And like I said to Phoenix 1328, my worry is that the vast majority of those will be fatal. So if they happen very often, then we'll go extinct. But, we'll see. All right, I'm yakking again, but I'm going to stop. Well, yeah, it is a cool idea. And it's, again, since the living computation idea is that living systems and computational systems are fundamentally the same, the fact that we're mortal, that I don't believe the science fiction stuff about brain downloading and everything, that's not going to happen anytime soon, because our configuration is this kind of mortal machine. It's intimately intertwined with all of the structures and the little things, and that hit that you got in the head when you were 6, and that drug you took in the college when you were 17, whatever, like that quantum limits is, there's just no way to get that information out. And if you had it, there's no way to have a piece of hardware to put it on, that could really do the job. Philosophical experiments, I can pretend brain in a vat, whatever. But no, in reality, no. And that's, not to get too gushy, but that's what makes life precious. That's what makes each machine, because that machine is mortal, and it shares a tremendous number of properties with its kindred machine. Lots of code is the same, but lots of things are unique, and its position in the universe, it's the fact that it's here now looking in this direction, is its stake in the universe. It's unique in that way. Anyway, okay. All right. So, there we go. Wanting to talk English and not code exactly. That's the kind of stuff that's just echoing a lot in my head these days. All right, well, how about we stop this and I go see about getting some lunch or something, and then putting up the video. So, folks, again, thank you so much for actually showing up live. It's really a wonderful thing, and taking the time out of your day, and actually, destination TV used to be a thing. Okay, I'm gonna stop it, and I will see you in the first Tuesday, the first T2sday in February.